Hello everyone, welcome to this IIRSM Southeast webinar. Today it's on the topic of dangerous substances and explosive atmosphere regulations, DSEAR. We are fortunate enough to have our guest speaker with us today, Graham Mitchell. Graham is an expert in this field based on his knowledge that he has on this subject, not just in the UK, but worldwide as well. Just before I hand over to Graham, if you do have any questions to ask of Graham during today's webinar, please do pop them in the Q&A box and we will go to this at the end of today's webinar. Thank you very much. I'll hand over to Graham.
Thanks, Katie. Okay, good afternoon, everyone, and welcome to this introduction to, you may have spotted a typo here on the first page. It should be dangerous substances and explosive atmosphere regulations. My fault. That's where DSEAR comes from. And the regulations were put in place in 2002. So in terms of agenda, what we have, I'm going to give you a brief introduction of who I am, some history, then we'll look at the European directives and ATEX, then the DSEAR regulations themselves, and then how we go about DSEAR actually in compliance, which is area classification. Some of you may be aware of the zones that come out of area classification. Then product selection, installation, competence, and what we call the explosion protection document, or some people in the UK, to give its correct title, is the verification dossier, which demonstrates your compliance to DSEAR. So a little bit about myself. As you can probably work out from the screen, I'm quite a senior electrical engineer now. Today I'm with AtkinsRéalis. I've been with AtkinsRéalis for over 12 years now, but I do other roles as well. I've got 40 years plus experience in the field, and originally I started my employment in armature winding. Some of you may not know what that is. Basically, it's electric motor repairs, and we're going back to the late 70s. The relevance of that is that in those days, in the late 70s, I live and was brought up in South Wales. There was a lot of coal mining, and then petrochemical came into the area as well. So a lot of explosive atmospheres present, and I was involved in repairs for those areas. I'm a technical champion for functional safety, DSEAR, and variable speed drive and harmonic solutions as well in my role here in Atkins. I'm lead engineer for DSEAR, but in addition to that, another role I hold is I'm an international auditor for EX equipment. So the manufacturer of equipment that's being used in explosive atmospheres. I audit organizations involved in that, but I also do the repairs as well. So organizations that repair such equipment, I'm a lead auditor for that in addition. I'm also lead engineer for risk management workshops, or safety management workshops. You've probably come across these HAZOPs, HAZIDs, CHAZOPs, layer protection analysis, which is LOPAs for functional safety, and other such workshops as well. And I'm internationally recognized for both DSEAR and for functional safety as well, and certified competent in those fields by international bodies. Enough about me. So if I just need to get rid of this so I can see my text, bear with me a second. So in terms of the European directives and ATEX, where did they all come from? Well, the original issue was the Seveso directive. In July 1976, a bursting disk on a reactor vessel at IIRSM chemical plant ruptured, and it released that toxin, a highly toxic substance. I'm not even going to attempt to say that. As a result, the plant itself, because it was located just 12 miles north of Milan, the disaster became known as the Seveso disaster. That was the name of the town. and it had a population of 37,000. Strange thing is that there were no human deaths, but there were 3,300 animals killed by this disaster. There were long-term health risks, including an increase in breast and lymphatic cancers, and several women, unfortunately, pregnant women, opted for abortions at the time. And yet there were no actual cases of complications regarding births. It was purely out of fear. So that Seveso directive actually became, in the UK, what we know as COMA directive. Yeah. So I'm sure some of you are familiar with COMA. That came as a result of the Seveso European directive, and which in turn then led to the ATEX directives as well. When, as I'm sure you probably all know, that these European directives have to be transferred into UK law. And the way in which this came about was the Dangerous Substances and Explosive Atmospheres Regulations of 2002. As you can see, these were passed under UK legislation to ensure that the essential health and safety requirements of the ATEX directives are met. And the HSE ACOP L138 states that the Dangerous Substances and Explosive Atmospheres Regulations of 2002, as set by the statutory instrument 2002/2776, set the minimum requirements for the protection of workers from fire and explosion risks related to dangerous substances and potentially explosive atmospheres. The regulations apply to employers and the self-employed at most workplaces in Great Britain where a dangerous substance is present or could be present. So what are the duties then under the regulations? So Regulation 4 covers those duties under these regulations, and Regulation 5 requires, as most health and safety Act laws do, that a risk assessment is conducted. So there's no surprise there. Regulation 6 looks at the elimination or reduction of risks from the dangerous substances. And these are things, as we call, we look at basis of safety. So you'll look at actually trying to reduce the substance in the first place, eliminate it. Yeah. So you should start by doing that. And that's what Regulation 6 talks about. 7 says that places where explosive atmospheres may occur, you basically have to identify them. And we'll see a little bit later in the presentation how we go about that. Then 8 covers arrangements to deal with accidents, incidents, and emergencies. 9 is information, instruction, and training. 10 is identification of hazardous contents of containers and pipes. So you may have seen like gas pipes are color-coded yellow, etc. And they'll actually have labeling on telling you what's within them. And 11 is duty of coordination. So this is where you may have an employee who's actually housed within an area which is controlled by another stakeholder. Example of this, there is a Welsh water site which is actually based on British Steel land, on old British Steel land. It's now Tata in Port Talbot. And the strange thing about this duty of coordination, people often ignore it. And as a result, there was an occasion where, unfortunately, there was an explosion at this plant, and the emergency services turned up at the security gates of the steelworks, only to be partially turned away when the gatehouse said, "We're not aware of any incident in our organization today." And yet it was, in fact, on Welsh water side. So the duty of coordination must never be overlooked. Okay, The explosion protection document then, as I said, where is it mentioned in the DSEAR? Basically, it's not. It's a requirement of the ATEX Worker Directive 137, but it's not a legal requirement under DSEAR. However, most companies now tend to produce it so as to satisfy regulations 5 to 7. And as I said, under DSEAR, what we talk about is actually a verification document. And this is required to be verified by a competent person before the plant is first energized. Okay, so whichever way you look at it, as I say, some organizations still call it an EPD, an explosion protection document. Others actually talk about a verification document. In fact, if I was being very accurate about this, I would say that often an explosion protection document is what starts out with designers. By the time it's going to be energized, it then becomes a verification document. So, as I said, how do we go about it? Well, the first thing to do once you've completed your risk assessment is area classification. And in order to do this, you have to identify the hazardous materials that you're handling, whether it's gas, dust, vapors, mist, sprays, coming off those materials. So typically within the water industry, where I spend a lot of my time, typical issues are what we call FLIDs, which is flammable liquids in drainage systems that end up in the inlet works to the wastewater treatment works. And that will obviously give rise to petrol vapors, which is highly combustible. We then identify the properties of these materials from safety data sheets to find out what their basic ignition temperatures are, the lower flammability levels, density, and things like that. And obviously, all of this information we're recording in what I would call at this stage an explosion protection document. Once we do that, then we have to look at where we're going to get potentials for release. Yeah, so where exactly is these vapors, gas, or ignitable dust going to come from? Typically, as you can imagine, just as an example, say Buncefield. Buncefield there, the actual vapors came from the surface of the fuels being stored. Yeah, and the release is out through any vent, yeah, because the tanks are vented. Then you have potential for release. If you have pressure relief valves as well, you'll get releases there. But in general, your basis of safety should always look to contain, yeah, because not only in terms of DSEAR, but you also face environmental issues and potential prosecution if you just don't take care of your containment. Then we determine the ventilation that might be present in those areas and the likelihood of the persistence of the explosive atmosphere. So again, if I use the Buncefield tank as an example, then any release around vents and PRVs are subject to natural ventilation. Unfortunately, for that incident, it was the actual rate of release that becomes the issue and the pure volume that escaped. Once you have all that information, you can actually calculate the type and the extent of the zone. And just so you know, in terms of zones, you get 3 possibilities and 4 if you count non-hazardous. So obviously non-hazardous is exactly what it says on the tin. After that, then you step into a zone 2, which is the least persistent of the zones, then into a zone 1, and eventually into a continuous zone, with continuous presence, which is a zone 0. And all of that forms the basis of the hazardous area plans. So, as I said, if we look at area classification, identifying the type and extent of the zone, typically a statement would say, we got a zone 1 internal with a zone 2 bubble of 2 meter radius around the point of discharge. So that there could be a typical area classification of a fuel storage tank. So in terms of how we look at those zones and how we judge it, as I said, if we start with the gas zones, a zone 2 would typically be a release that is 10 hours a year in terms of presence. And when it is present, it's typically less than 1 hour duration or about 1 hour duration, not more than that. If the persistence and presence becomes longer than that, between 10 and 1,000 hours a year, then you're looking at a zone 1. If it becomes greater than that, again, you're into the continuous presence. Again, an example of that would be the internal of a fuel tank, a storage tank such as Buncefield. Then if you look at the dust zones, you have a similar thing, but they just call them 22, 21, and 20. Okay. Just as an example then, what you can see on the screen in front of you is a typical area classification. Here we're seeing a combination of dust zones and gas zones as well. So you can see on the right-hand side, it indicated as zone 2s. And then when you move towards the left, all the zones there that indicated as zone 21s, 22s, which are dust zones. And you can see it clearly identifies where they're internal to the silos or you've got external zones. So that happens, I think, most of those are all internal zones. And it's important as well, just as note that when people are drawing this, that they should use the patterns you see, not the colors, there's no stipulation on color, but they should use the patterns that are dictated in the standards. And there is another example, which in this case are all dust zones. So you can see it's there's a lot of explosive atmospheres about in some of these works. And dust, just to note that dust can be a lot more problematic than gas actually, because we often know very little about the materials we're handling in terms of dust. So it's not an easy exercise for us to clearly conduct a risk assessment. So now we'll look at product then. You can see we've done the zoning now and we've identified where all these explosive atmospheres are. What we now need to do is say, well, okay, what do we do next? Well, as I say, we identify what zone is applicable from the drawings and the tables, because we do have tables that we use in the risk assessment to determine the drawings. From that information, we'll be able to identify what we call the temperature class or the T class required for the installation of equipment. And then also the gas subgroup or dust subgroup. So then it may look as simple as just select the correct product. You would like to think so. Yeah. So you have all these explosive atmospheres and somebody has to say, well, is this suitable for this atmosphere? And there are differences. As I said, in terms of the gas zones and dust zones, there are 3 different types. And in order to pick the correct type, you have what we call equipment categories or protection levels. Basically, I can honestly say they're kind of interchangeable. It's just one comes out of one compliance route, which is the IEC EX compliance for of equipment, and the other is actually the ATEX requirement. So ATEX talks about categories and IECX talks about equipment protection levels, but effectively, as you can see, they're almost interchangeable. So if you were picking a piece of equipment for the zone 0, you've either got a 1G or a GA piece of equipment. Often it'll be dual certified, okay? So it'll come as a 1G and a GA, and you'll see the markings in a moment. And then if you wind down through the zones, so zone 1, obviously if a piece of equipment is good enough to go into a continuous zone, then it's good enough for the zone 1, yeah? Because this is the highest level of protection is the 1G and the GA, or the 1D and the DA. So you have your selections there. Just so you know, often a piece of equipment will be suitable for the gas and the dust zones, in which case it would be marked 1GD or GADA, okay? So if you're wondering how you would identify that, it's on markings like this. So when you're looking at a piece of equipment that has such markings, you know it's suitable for explosion protection because it's got the EX in the hexagon, yeah? Then you've got what we call above ground application. So it's Roman numeral 2, which means it's above ground, not mining. If it was mining, it'd be group 1. Then, as I said in the previous slide, you've got your equipment category, in which case this is 2 GD. Yeah, so gas and dust is suitable for. And after that, we get the protection concept. Here you've got EXD. It's a type of protection concept. It's the way in which the equipment is built that stops it becoming an ignition risk. EXD happens to be what they call explosion proof. And it uses things that they call flame paths, such that if you do get ignition within the equipment, any flame or hot gases will actually be quenched by those flame paths before it hits the outside atmosphere. And that's the protection concept. Down below, you see the same, but now it's got what they call an increased safety terminal box, as shown by the E after the D, in which case everything except the terminal box is still D, has flame paths, but when you get to the terminal box, it relies on ignition prevention through clearances and creepages and IP protection. Then you get the 2Bs, which is the gas subgroup. Just a note on that, there are 3 different types, 2A, 2B, 2C, and it's really to do with the characteristics of the gas and the kind of, I wouldn't say volatility, it's more the ability of the gas to get through small gaps. So for instance, on the flame path, if you had a 2C, which is the highest classification of protection for subgroups, then that would have the smallest gap and the longest flame path. And typically that would be used for hydrogen gas, acetylene gas, because that gas has been shown to get through smaller gaps than methane. Methane would be a 2A gas. Then you add the temperature class. There are 6 temperature classes, and this determines the actual surface temperature of the equipment, okay, against the gas. So if you had a gas like methane, which off the top of my head is about 420 degrees C, you would have to pick a T class where the surface temperature did not get anywhere close to 420. So it's likely to be around 350, 370, and then a fixed temperature classes of equipment going from T1 to T6. Then you get the ambient temperatures the device is suitable for, and then finally the equipment protection level, as we saw, which again is gas in this case, and it's actually B classification, which is suitable for the zone 1. The interesting part of the equipment protection level, if you look, it doesn't have an equivalent dust. Yeah, in the category group, it was suitable for G and D. But strangely on this marking, in terms of equipment protection level, it doesn't have a dust marking. And as I said, they're actually different certification schemes. Oh, apologies. The dust marking is below, that's why. They put all the dust markings below, which is DB, with the IP66. Yeah. Here on this line, you have, as I said, the dust markings. That's why it's 3C. So in this case, the Roman numeral 3 is used to signify dust. The C is the type of dust that you're handling. You go from a conductive dust, a non-conductive dust, and what they call fly-ins. Then you can see the strange thing about dust is it has 2 ignition points. So they actually stamp the surface temperature, or the highest temperature that equipment will get to is stamped and shown clearly as opposed to a temperature class. So you can see it's 135, won't get any hotter than that. And as I say, the ATEX and ICEX markings are shown for the different categories of equipment. Yeah, GA, DA, etc. And what this is showing is the required protection. And as I said, when you talk about zone ones, for instance, equipment category 1, sorry, and zone zeros, it's the highest protection of all, in which case it will actually still function and protect itself with 2 faults, 2 independent faults. Whereas when you get down to category 2 equipment for zone 1, it's 1 fault protection. And then the lowest protection of all is just normal operation. Hence why you get the different equipment categories suitable for the different levels of explosive atmosphere. Again, on product selection, what you see in front of you are the 2 different certification schemes. You've got ICEX and you've got ATEX. So you'll have a product that can be marked with maybe just this one on the top line, which means it's ATEX certified, or it may be that it's ICEX certified. And to throw a bit of a curveball in, we now have, thanks to the British government, the UK EX certification as well, which I don't show currently on this. Yeah, but basically this all resulted from Brexit, and now the UK government has stated that actually they will carry on with the ATEX certification. So there were a lot of people out there that don't exactly clap me when I turn up as an auditor, because they went and paid for UK EX certification when they actually didn't need to, because the government backpedaled and said, we'll carry on with ATEX. Yeah. So this is the actual markings you would be seeing on certified equipment. Now, the reason I say that is because there is a strange difference between the 2 schemes. We follow very much ATEX within Europe and the UK. Unfortunately, under that regulation and DSEAR, equipment manufacturers of electrical equipment are allowed to self-declare, so they don't need a certificate for category 2 equipment, the lowest level. So they can actually just self-declare, and nobody independently audits that or checks on the compliance. And for mechanical equipment, they can do that up to category 1. Under the IEC scheme, you cannot do that at all. Everything must be certified. And believe me, as somebody who audits and is involved in the engineering world, I can tell you, my personal belief is we should all go across to the ICEX, because I'm seeing far too many manufacturers dodging the bullet with their self-declaration. And as I said, what you see there is further examples of marking. And here's some very real marking. If you happen to be interested and pop your head around the corner to look at a motor that was certified, what you can see down here in the red box is the certification. Yeah. So it's this type is EXNA. So it's a non-sparking piece of equipment above ground by the Roman numeral 2, T class 3. Then you got the actual certification body there, VTT. 06 is the year, so 2006, this certificate was issued, ATEX, then you get a unique number. Now the X on the end, again, is actually special conditions. So actually this is something that gets overlooked. If you ever see this on the nameplate, what the installer should do is get the certificate and read those special conditions, because it'll have critical information on there which must be complied with. Again, just a variation on this as well. This actually is a CSA marking for the American market, and you can see it's very different. You've got divisions 2 and 1, 3, sorry. So you've got groups A, B, C, and D, because this is a different certification. It's a different scheme altogether for the North American market. They don't come under ATEX, ICX, although a lot of manufacturers and even end users out there do like those schemes. This is an example of a mechanical piece of equipment. The reason I put this is because they actually have the certification body number on the CE marking. You can see that clearly, and that's the requirement. And you can see the ICEX certification at the top, again with X's on. So there's special conditions. It's just a different protection concept. This is a dust, this is environment, and you can see it's what we call EXP, which is pressurized. And it's the same with the gas on the line above. So this is the gas, this is the dust, and it achieves its protection through being positively pressurized. And if you positively pressurize your equipment, it means your explosive atmospheres can't get inwards. Yeah. Quite common on if you're putting control panels and things like that into explosive atmospheres. They often will have EXP and very large motors as well. As I said earlier, X indicates that special conditions apply, and it's vital that you actually get the certificate and read those, make sure you apply them. So the verification dossier then, the document itself, it contains all the relevant design installation information, including but not limited to. You'll have the risk assessments, the HAZOPs, ever safety management information, all the hazardous area classification assessments, including the drawings. You'll have process descriptions, basis of safety, ventilation details, the mechanical and electrical installation certificates, including gas systems, all certificates and declarations for the equipment. But the thing is, it must be signed off by a competent person. So what is competence? I've done 2 presentations now in the space of a week, and I pretty much put the same slide up there. What is competence? How do we judge it? Believe me, it gets talked about an awful lot, but the judgment and the continued presence of competence actually, I think, is still a challenge to us all. As I said, I'm a firm believer when it comes to the equipment that it all should be certified, because my own experience out there as an auditor and working elsewhere as well, not just auditing, is that we seem to be missing, we're losing a lot of competence in the industry. And as a result, people who are able to self-declare, can you imagine how dangerous that is? Because there's no judgment of their competence. When I'm auditing and I go to somewhere who are certificated, I actually have to make a judgment on their competence. And if I'm not happy about it, they run the risk of losing their certification. But if you can self-declare, none of that applies. So that was a whistle-stop tour into DSEAR and what it's all about and how we go about it. I hope it's been informative, and I open the floor to questions.
Thank you, Graham. That was Extremely informative, thank you. It actually took me back quite a few years to when I first started actually in my health and safety career, and I found myself on petrol forecourts trying to learn about different zonings. So yeah, just talking about the patterns there as well and not worrying too much about the colours, yeah, it all come flooding back to me there. So no, thank you. That was really, really informative. We have got a couple of questions for you, if that's
Yeah.
okay. So the
Yeah,
first
sure.
First one is from a gentleman called Greg, and he says, "Hi Graham, are there any plans to harmonise the scheme's equipment classifications, bearing in mind they are so similar?"
I take it he means the ICX and ATEX certification schemes. I don't believe there are. I think it will be a case of if Europe, in the first place, decide to move across to ICX. I mean, ICX is an international scheme, so it's worldwide. It's actually acknowledged by the UN and encouraged by the UN, of all people. I do have a clip somewhere hidden away that mentions that. And as I said, it really does give you assurance of the compliance. Whereas once you go across the self-declaration, we all know that, yeah, what's possible under self-declaration, unfortunately. But no, there there are no plans because they're two very different schemes, and it's kind of like turkeys voting for Christmas, I guess. Yeah. Um, but I hope that in time it will just go across to ICX.
Okay, thank you for answering that. While we're on the topic of equipment there, we've got another question that's just come in. Is there a requirement or regulation for ATEX equipment to be serviced or tested, the enclosure integrity? Is there a requirement or regulation for ATEX equipment to be serviced or tested the enclosure integrity?
Yes, it is. If I take it's actually two questions there. If I take the serviced, then it should be serviced in line with the manufacturer's recommendations. Yeah. And as I said, I actually audit for the ICEX repair scheme as well, and I would strongly advise people who are getting their EX equipment repaired, seek out such organizations, and there's lots of them in the UK. In terms of the enclosure integrity, yes, because if there is any damage to that, it means your IP, your ingress protection is damaged. And at that point, you can lose your protection concepts. They can be um, compromised. Yeah. In which case, then, as I said, you've lost all your explosion protection. So yes, that is a requirement. And that would be checked under the repair scheme. So if you engaged ICEX repairer, for instance, explosion protection concept that I described, the flameproof, if that's compromised, the idea, I described the idea that the flame path would quench any hot gases, etc., and any ignition sources. But what it also does, it contains the explosion. So actually those motors and enclosures are tested to a pressure. And so if there's any doubt by in the field, the end user doubts that his enclosure might be correct or might be compromised, he can send it to a repairer who will conduct that pressure test. So yes, it's very important.
Thank you, Graham. The questions are flying in now, which is brilliant. In educational and research laboratories, where would you draw the line between DSEAR and just COSH risk assessments? And there's an example given. For example, piped in gases, even gas bottles in the room in older facilities, and the other extreme, a bottle of flammable solvent.
Okay, a bottle of flammable solvent would come under COSH without any doubt. If you start, it's all about quantities, and in the standard and in the ACOPS, it will talk about quantities. Bottle gases, for instance, I believe it's something like 250 liters or so. Yeah, so it's quantities. But when you got piped, if you got natural gas within your house, for instance, that would be covered by what we call the IGEM standards. So, which is the gas standard for gas installations, domestic installations. When you talk about industry, once you talk about pipe gases, etc., yes, you have to assess for those and identify where they are, etc., etc. So when we're on water sites, we have biogas, for instance, which we generate ourselves. Then we'll identify those gas lines and any natural gas coming in connections. Although at that point, it's still identified and still assessed, but it tends to then become part of the network operator's responsibility as opposed to a water industry responsibility.
Fantastic. Thanks, Graham. Whilst we're on the topic of risk assessment, we've got another question. Does DSEARS need a risk assessment? How do you make this? Is this scored like a hazard, HAZID?
I wouldn't say it's scored as a hazard. That kind of question, I'm not sure what they're pointing to in terms of scoring, but it would be risk assessed just like you do a normal risk assessment in terms of consequence, yeah, probability and severity, yeah. You would look at it from that point of view. That would be your first start point. And then you would move on to the actual assessment of the gases or the substances themselves, yeah.
Okay, thanks, Graham. Whilst you spoke about then, something just flew into my mind, and sadly since Grenfell there's been a lot of focus, quite rightly so, on fire. Do you feel that it's worth combining the elements of DSEAR into a fire risk assessment and maybe back the other way as well, or and maybe have both combinations, or is it worth keeping everything separate?
The strange thing about the regulations is that that list that I read out at the end in terms of the verification dossier, it's not stipulated how you keep that, yeah, and where you keep it. So in fact, what I'm saying is it doesn't all have to be in one dossier. Yeah, you can actually have something here in hard paper form, if you like, and then another part of it could be on a database somewhere. Yeah, and with reference to the fire risk assessment, then yes, I believe that within the majority of documents I produce does not include that. Yeah, because you generally find in industry they have their own department that looks after fire and all the fire risk assessments, etc. Yeah. And that's almost a given within when we're compiling our documents, we generally don't even have to refer to it because it's kept somewhere else and it's somebody else's responsibility. And often those people, no disrespect to them, but often they don't know enough about the explosive atmospheres to actually step, if you like, across into the environment that we work in. Yeah.
And I guess that goes back to that competency slide as well.
Yes, exactly. If I had any issues about fire safety related to the documents I was producing, I would talk to the people with that competence.
Yeah, definitely. Our next question: we are engaged as a contractor to undertake work in confined space manhole chambers. Is it the confined space manhole chamber owner whom is responsible for zone classification?
Yes. In terms of area classifications, it is the owner responsible. Yes. But please remember, they should do an assessment. It depends what they are actually trying to describe to me. So the fact that it's a confined space does not make it a hazard in terms of explosive or combustible. Yeah. Although, you have to be very careful because it's oxygen depletion is the biggest risk. So yeah, and the other thing on that score, which is worth pointing out, that unfortunately sometimes when there is a risk of oxygen depletion, we've known organizations provide forced air ventilation and they've over oxygenated the area, and somebody has gone in with a grinder and literally it's resulted in fatalities through over oxygenated environments. So that's the thing to be careful of when you're working in confined spaces, amongst the other things that go along with confined space and gas testing. But if there is, even just to say there are no explosive atmospheres or releases present, that assessment must be done. And it's the end user, the owner, that must do that.
Brilliant. Thank you, Graham. Just looking at our Q&A and chat boxes there, that looks like that's the end of the questions currently. If anybody has got any more questions that they'd like to pose to Graham, please do get in contact either with us directly at IIRSM South East Branch, or I'm sure Graham wouldn't mind taking those questions and answers directly either. Thank you, Graham. That has been really insightful. As I say, it took me back quite a number of years, but it is such a informative topic, with so much discussion around it as well. So thank you everyone for joining today's webinar. As I say, if you do have any further questions, please do let us or Graham directly know himself. And yeah, thank you, Graham. You've been an incredible presenter. Thank you very much.
No problem. My pleasure. Thank you.
Thank you.
Thanks.
Thank you. Enjoy your